name the quadrant in which the angle theta lies. Name the quadrant in which the angle theta lies. So the first condition we are given is that name the quadrant in which theta lies if the tangent of theta is positive and the sine of theta is negative. So if this is negative while this is positive. And then the next one says name the quadrant in which it lies if it satisfies these two conditions. So the first condition is if the sine of the angle is positive and the cosine is negative. Anyway, the best way to answer questions like this is to draw the four cardinal points. So let's say this is you have something like this, something like this. So this is what we have. So we said if you want to sketch an angle, so you start with 0 degrees. So by the time you move to this point, you would have covered 90 degrees. And then down here, you would have covered 180 degrees. Then back here, you would have covered 270 degrees. And then down here, you would have covered 360 degrees. So again, you recall that we called this quadrant, quadrant 1. Then back here we call this quadrant 2. Then the next quadrant is quadrant 3. Then this quadrant is quadrant 4. So that's what we know. And again, in terms of which quadrants do the trigonometric functions, do they have a positive value? So we said a very good way is to remember this acronym. The acronym is ACTS. ACTS, when you go you go clockwise anyway. You go clockwise. So this is going to be A, then this will be C, this will be T, and this will be S. So what this means is all. Then this one means the cosine, this is for tan, and this is for sine. So what this means is all trigonometric functions of angles between 0 and 90 degrees, they are all positive. So they are all greater than 0 here. But for this one, it means the sine of any angle, the sine of theta, and obviously the sine of theta is positive for all angles between 90 and 180. So obviously, if the sine of theta is positive, then 1 over sine, that is 1 over the sine of theta, because 1 over a positive number is going to be positive, right? So it would also be positive, right? So but then 1 over sine is the same thing as the cosec of theta. So this is what we know. So if sine of theta is positive, the reciprocal will also be positive. So every other angle is negative, that is others are negative. Others negative. Now here the tangent of theta is positive, and definitely the reciprocal will also be positive. So that is the cotangent of theta will be positive, but then others are negative. While here the cosine of all angles between 270 and 360 degrees, they are positive. So the cosine of theta is positive, and definitely the reciprocal, which is 1 over the cosine, and that is the sec of theta, is also positive. So aside this, every other angle, the trigonometric function of every other angle aside the cosine and the sec, others are negative. So now we know this. Let's now come back to the question. It says name the quadrant in which theta lies if the tangent is positive and the sine is negative. Now of all the three quadrants, this is the only quadrant that has theta, the tangent, to be positive, and we said every other one they are negative. So that means the solution to this problem must be quadrant 3. For the next one, it says name the quadrant such that the sine is positive but the cosine is negative. So of all the quadrants we have here, this is the only quadrant that has the sine to be positive and the cosine is negative, because we said it's only the sine and the cosec that are positive. Every other ones are negative. So definitely, since the cosine falls in every other one, then it must be quadrant 2. So the quadrant is quadrant 2. So that completes the problem.